Thank you very much for coming. My name is Conor Cunningham. I decided to give a talk on the query store. I invented the idea behind the query store a number of years ago, and I've been working closely with a number of my peers at Microsoft to sort of make the dream a reality. And I thought I'd give a talk a little bit about the lessons learned and looking back, what sorts of things were interesting and challenging at the time that we were trying to build it. So this talk is about sort of what we've learned over that time. So a bit about me. I have worked for Microsoft for 25 years over 2 different stints. Basically, my career has been building database engines, query optimizers, query processors, that kind of thing. And so a lot of the work that I did early in my career was looking at how to make the query processor better, and specifically whenever customers would open up support cases, we would often get issues from customer support that would come to us where the customer support engineers couldn't answer the questions, and therefore they wanted the actual software engineers to dig deep into the code and to go figure out what was wrong. So that eventually led to a bunch of repeated kinds of patterns that we would see, and I used that to kind of come up with what the query store would eventually be. I also wrote a book chapter on how the query optimizer work, and I've been here at BITS talking about how query optimizers work in SQL. And then I've also, over the years, gotten into the fun part about working at my job is sort of taking big customer problems and tuning very interesting new problems where they've been trying to do something that we haven't done before on SQL, and that exposes a number of different challenges where maybe SQL can't do quite what we want, so we have to build a new feature to help them. And eventually, I sort of specialized in trying to figure out how to optimize and tune applications. And as we've gotten into the cloud, it's actually gotten even more interesting for how that works. And then, as I mentioned, I did the original idea for the query store, but I don't want to take credit for implementing all of it. There's a lot of very, very smart engineers with whom I've worked that deserve much more credit than I do for building it. But the ideas behind it, I hope, help shape how we think about solving problems and how do you potentially think about building a net new application to take advantage of that when you're using SQL in the future, either SQL Server, SQL Azure, or hopefully in the future Synapse. Okay, some fun facts to get this started. Originally, it was called the Query Disk Store, and if you go look on the file system, there's a DLL called qds.dll, and so that's why it was called QDS. We eventually changed the name because they didn't like the word disk at the end, so marketing or whoever it was told us to change it, so we did. I originally came up with the idea, I think roughly 2008, but the feature itself was canceled 3 times before it could ship, so it took me 7 years to get it released, eventually in SQL 2016. Sometimes it was canceled for good reasons. So for example, one time it was canceled because we had to go build what became column store indexes, which is extremely valuable as a feature as well. Other times there were some features that never shipped that it was canceled for, so I'll say those maybe weren't quite as good of an idea to cancel my feature for. So one of the interesting parts about trying to get a feature done at Microsoft that I should explain is often when we're building features in SQL Server, we have 10 times more ideas than we have engineering resources to build. So as a result, you're basically canceling 90% of the ideas as what you're doing for feature planning. And as a more junior engineer, it's harder to get your features to the top of the list. And so, sometimes you can get them canceled over and over again as a result of that. Now, the great part is I am stubborn and Irish, which is redundant. So eventually I outwitted my opponents and eventually got this to the top of the list. And when we actually shipped SQL 2016, this is the most popular feature that went out in that release. And in fact, in SQL 2022, the one that just went out last fall, this query store is now on by default for a number of reasons. So I'm hoping that you will take advantage of it because there's a lot of interesting things it can do to make problems that used to be very, very painful and require an expert to go debug. Now you can do without necessarily being an expert, and sometimes even automatically it'll fix the problems for you. So another fun fact is when I first designed the query store, what I intended to do was to binary serialize all the plans, meaning you wouldn't have to recompile to execute a plan once it was in the query store. And this idea was a great idea, but my eyes were bigger than my stomach, so to speak, because doing that would require that I could guarantee over every single future release of SQL as we changed the binary from build to build, that I could guarantee that all prior serialized plans would always be runnable. And at the end of the day, that proved too big a task to actually really deliver on. So what we ended up doing instead was storing show plans in the query store instead, which meant that if you wanted to force a query plan, you had to go and run through the plan forcing mechanism that we already had, which is a 98, 99% good solution, but there are cases where it doesn't necessarily work. And so ultimately, that was one major difference from what my original design plan was, but it turned out to be practical in terms of getting it out to market, given that I had to work to get it refunded several times. Another fun fact is at the time, Rohan was my boss, and when we got the query store funded, we only had funding to do the engine. We didn't have any funding to do the UI that you see in Management Studio today. So once I got it funded, I clandestinely went to several of my colleagues that had a few spare resources, and we basically decided that we would fund the UI without telling the boss. And so one day I grabbed Rohan and I pulled him into a room and I said, sit down, and I had them do a demo of what was the Query Store UI in SSMS, and he had this giant grin on his face. So I felt like that was a much more useful way to get things funded at work than asking permission. And that's pretty much what I've done since then. And the last thing I'll mention as a fun fact is when I originally wrote the paper that became the Query Store, it was like an 80-page vision document of all the different things I wanted to do. And I'll just say, while we've done a lot of things in SQL 2022 on things that were in the vision paper, we're not remotely done with all the things that I originally wrote down that we could do with it. So I think there's a lot of opportunity still in the future for us to continue to add scenarios to make it easier for you to do your jobs when you use SQL. Okay. So I wanted to kind of go through what troubleshooting was like and what that looks like to a customer outside and to us inside of Microsoft when you didn't have the query store. Often, the way that things would work out is you're running your application, you're happy as a clam, all of a sudden, SQL gets slow, you don't know why, your application times out, you open up a case, you yell at the customer service engineer, they turn around, eventually come to the engineering team and go, we need to know what changed. And so we would take some PhD level engineer and say, please go debug why this changed. And sure enough, we would spend a day and we'd come back and we're like, oh, yeah, we guess certain things about how cardinality works when you're trying to join between two tables, and you're not doing it exactly the way that we guessed, and therefore the plan changed, and now it picked a different plan that was just about the same cost, but not quite, and now you get a slow plan. And we go back and tell the customer that, and the customer's sitting there like, my app is still broken, what happened? And the answer is they asked the wrong question, right? Certainly it's interesting to know why it changed, but that's not the real question. What they really want to do is get back to a working state as quickly as possible. And you really want to separate what is root cause from what is mitigation. And the problem is that the typical model for an upset engineer is to tell me the root cause now. Why? As a form of technical dominance, you must explain to me what you have done wrong. You know, sort of scolding. Not that that's a wrong reaction when you've paid money for software. I don't want to suggest that you don't have the right to say that, but that's actually not the best question to ask in terms of making sure that your application works. It's great if we can go do the root cause analysis on what went wrong and make sure that we learn from that and work on improving our software, but it's actually far more important that we get you back to a working state as quickly as possible, or potentially not even let you get into an unworking state because the system learns what's going on faster than you can react. And the whole idea of the query store would be to figure out how we can actually do something. And the real key lesson of what the query store did was to say, you know what? I'm going to store the history of all the plans so that you can go back to the one before. If it's performing better, I want to show you that it's performing better. You can see that really quickly, and you can force that plan faster than you can do a CSS case. And by doing that, I separate you wanting to know why it changed, which is still a valid question, from the my application's down and I'm losing money question. And that shows up in lots of different ways. But that's the key insight as to what the query store was trying to do. Previously, people would be snapshotting DMVs and trying to build scripts to put them in a different database and then look at the history. No one asked us to build the query store. They would always ask us for a better horse, effectively, or a faster horse. And ultimately, when we went and built the car that is the query store, we gave you a mechanism and a set of verbs that didn't exist before in the vocabulary. And if we go one step beyond that, what the query store actually ends up becoming is a place where once you start running repeated queries in a workload, we can learn from prior executions and make future executions better. And so once you get to the insight that this is now a place to store wisdom from prior executions and to learn from your workload, we can now think about how to build query processors and query optimizers in a very different way than what happened before. And as a result, that opens up a whole realm of possibilities if you design this to be correct, so that you don't necessarily overwhelm a workload, and you figure out the right balance between I want to capture enough of your workload so that I can learn from it and avoid mistakes, and separately not give you too much complexity about how you have to figure out how it works. How many people remember when you had to go figure out like which query statement it was in the DMV, and then figure out if its plan was there, and then get the runtime stats out? Have you ever done that cross apply, figure out the UTF-16 2-byte offset crap? That was the DMV. So I actually also invented the concept of DMVs, although I didn't invent the particular DMVs for that entire scenario. The whole problem behind DMVs originally was similar. We needed to give some insight for supportability into the product, but what we were really doing with DMVs is giving you these little tiny windows down into the engine of SQL in terms of how it was implemented. And you had to understand exactly the mechanisms behind what was underneath the covers to get any sense of reality of what was actually there and what you should do about it. We forced you to become an expert in the internal architecture of DMVs, or the engine, to be able to get any insight into what you should do to fix your application. Oh, I need to add this hint right here. Query Store said, you know what, I'm actually going to change that equation. I'm going to up-level this conversation to, you know about a query, you don't need to know about the UTF-16 offset within a statement about where your statement starts and where your statement ends in order to figure out what the query plan was, if it's still in the cache. No, we're going to separate, is it in the cache, what is a query, what is a statement, and build a schema around that so that you can understand exactly what in your business logic makes sense. And then take actions based on that for repeated query executions as the mechanism in the model for what we're going to expose. So we're going to change and up-level this to something that's closer to what you, the user, can understand and take action on. We want you to be able to figure out, okay, how do I quickly get insight in a way that makes sense to me, as opposed to I'm going to go get underneath the covers and really understand what's happening in the carburetor of this engine in this car. Okay, so for those of you unfamiliar with the Query Store, this is the rough table layout that ended up happening. And I'll just walk through it to make sure that we have a baseline for everyone here today so that you can kind of understand the rough idea behind how data is stored in the Query Store and how decisions get made. So at the base, the topmost table is called sys.querystore query text. I took the prefix off of these to make it easier to read. And sys.querystore query text is for each statement, meaning the beginning of the first character of the first token to the end of the last character of the last token of a statement. Capture that and put it in a table, and then give it an ID, a surrogate ID. And so we have a query text ID that represents each unique text that you get. Now, for those of you unfamiliar, inside of SQL, if you add a space in the middle of a SQL statement, that's a different statement as far as the engine's concerned. Because the way that the original caches worked for deciding whether do I recompile or compile a new plan is whether or not the exact text that you came in with is what was there before. So we just look at the text, we do an MD5 hash of it, we figure out if it's the same. If it's not, we compile again and just use a different cache entry. So there is some amount of precision here. You can't have uppercase, lowercase differences. You can't have extra spaces. It has to be exactly the same text. So we needed to keep that idea because that's how the rest of the system worked, and we could make some statement that we were being consistent with how our statements are captured. Within a statement, once you have a query text, you have this notion of what is a semantic interpretation of a query. So in the United States, the date format is a particular way. In Europe, different date formats are there. There's different decimal separators. And each of these things sort of change how do you interpret what is a SQL statement, and how do you interpret the literals or the dates or anything like that. And so we have a set of information about each query text can have one or more semantic interpretations, and that's what we call a query. So an interpretation of a query is a query text plus some information about the context. Is ANSI nulls on or off? What's the first day of the week? What's your date format, et cetera? So usually you only have one, but there might be multiple because sometimes different client drivers expose slightly different context settings. And so we had a table that we put together called context settings, which was for each unique combination of all these different query settings. We would put a row into this table and say, yep, if you've got this is your date format and the first day of the week is Sunday and then context settings would give you an ID. And so that context settings ID plus the query text ID would give you a unique query ID. Once you have a semantic definition of a query, then we can move on to, okay, what's the history of all the plans that you saw? For each query, you'd have one or more plans, and we'd record each of them in the plan table. And that became a show plan, plus some information about what it meant to compile that plan. How long did it take to compile? When did we do it? So that you would have a notion of history. You, the user, the DBA, could say, yep, this is the plan, this is the first time I saw it, this is the last time it was used, et cetera. The final main concept was once we have a plan, over time we want to know, okay, how did it perform? And when we did initial experiments for the query store, we said, well, we can't capture every single query execution. If you want to do that, you can just go do an X event trace. We need a way to summarize this information so that over time you can understand, okay, was it performing better today versus yesterday, or an hour ago versus now? And so we started off with a model of a date bucket, or a runtime stats interval, which basically defaults to an hour, and you can change the setting down to a minute or up to a day or whatever, so that you get a sense for, okay, how much data do I want to capture? How much granularity do I want to have in terms of understanding history versus what's the overhead of what the capture might be? So we defaulted it to a couple of things that we thought would work for most applications. An hour works pretty well. And then we have some additional policies on capture, which I'll explain in a minute. And then we say, okay, well, we'll summarize per hour. And we ended up storing a lot of information for each dimension or attribute you'd want to capture. So we'd have, say, the compilation time or CPU time, duration, so wall clock time, and we would capture min, max, average, standard deviation, and last execution for each of these metrics. And so each of those would be captured, so you get a sense of what's happening, not necessarily a perfect record, but enough to usually make a decision of, if my query is slow now, was it faster an hour ago? And we want you to quickly be able to determine that. So we have a runtime stats interval table, which keeps track of the boundaries. And then later, customers were asking for, can you help me understand what my query is slow on so that I can look at before and after and get a sense of that? Is it slow on parallelism? Is it slow on waiting for the CPU? Is it waiting on I/O? And so we put a summary of that type of information together and created a wait stats table that shipped in a later version than 2016. But it's the same idea as the runtime stats. Are there any questions before I move on about the schema? Underneath the covers, what ends up happening is we capture all this information into memory, and then we'll persist this to disk in the background. So we have a cache of a lot of this information in memory, so that it'll go fast. And then historical information gets purged as we go through running your application, and that gets persisted to disk. And then when you go query one of these sys.query store tables, we're uniting together the on-disk information and the in-memory information, so it looks seamless to you. At the time, I called this magic pixie dust because no one believed me that we could do this. Okay, going one step further, another challenge that we had when building the query store, before the query store happened, back in the, say, SQL 2005 days, we would have service packs. And we would put bug fixes in service packs. And so if we had a problem in, say, cardinality estimation in the optimizer, we'd go through, put a fix in, and one of the challenges when building query optimizers is 2 wrongs can make a right. So if you might be wrong at the bottom of a query plan in estimating how much it might return in terms of how many rows, but later on you may correct that by misestimating the other direction. 2 wrongs can make a right. You might get a good plan when you have those 2 problems in the query, and you fix one of them, then you expose it, all of a sudden you get a bad query plan as a user, you're unhappy. So it got to the point where we weren't really able to make major changes to the optimizer because of the risk of regressions. And as a result, we had several people leave the team because we just weren't making enough progress to make it interesting to have the kinds of PhD level engineers that you would need to do that kind of problem. So one of the things that we were very mindful of when we put the query store together is we wanted to figure out how do we make sure that the query processor works as is and the query store doesn't change that. It gives you a level of insurance. It doesn't change and force you to get different paths of behavior because of how the query store gets added into the system. So we made the query store look like an observer, meaning it's watching, just like you would, what the query processor is doing and trying to record that, but not trying to change the behavior of the query processor by default. And when we start going down the path of things the query store can do, the first verb that we exposed was, yep, we want to be able to force the old plan, and then if it doesn't work, we want to unforce that plan and get back to whatever the default behavior would be, so that we have the principle of least surprise. Because it's very hard to debug these things, and the whole intention is to make it easy for you to get to a working state. We don't want to get to a third state that doesn't have any history so that you don't understand what it is, because that's just a different CSS conversation if you're in a bad position with your application. So we really wanted to make sure the query store was additive and not the sort of thing that forced you into a different concept of debugging. It gives you different tools, but if it's not working, you can just turn it off, you get back to where you were. You're no worse off than you were before. And that meant that it wasn't as scary for people to turn on, and as they start to play with it, they'll understand that it's actually something that's designed that way on purpose to separate risks and concerns so that you can build applications in a way that you can reason about quickly in the sense of a live site down situation. Are there any questions about this? Okay. All right, so I mentioned the query store UI. This turned out to be quite interesting because when I started working on this without permission from my boss, we went and had to talk to all the people that do UX design, and they were adamant that I must have circles. I was going to say just a line would be great. No, circles. I'm like, okay, circles it is. And then it turns out that the circles were interesting because we make them different sizes and different colors, and it turned out to be kind of an interesting design paradigm, but ultimately we had to go through a series of iterations to figure out what kinds of views would make the query store useful to you. Initially, you could kind of query the table yourself however you wanted, but we wanted to make it really easy to say, show me the queries that have changed in the last hour, show me my top hitters, show me my workload over time. And so we developed a couple of these over time to let you kind of quickly sort of look through what we were capturing and to give it enough ease of use that any person who had some idea of roughly what their application was trying to do could look at this, figure out what the biggest queries were and where they should spend their time. That way, when you start looking at the data in the query store, you can immediately get value out of it. I do not claim to be a UX expert. In fact, I'm pretty much claimed to be the opposite of that, but we did at least do a good college try at putting the query store UI together in a form that has added a lot of value. There's definitely some things I would change in hindsight, but overall, given that I didn't have any funding to build this in the first place, I'm extremely happy that we were able to put something out that's been able to add value for many years without necessarily breaking the bank in terms of engineering cost. So ultimately, I encourage you to go play with turning on the query store and playing with the UI in your application because you can find a lot of interesting things about what's going well or not well in your app. I mentioned earlier that I sometimes go and consult with different teams, sometimes within Microsoft, sometimes external companies, about how their application is performing. One of the main things I do is get them to turn on the query store, run their workload, and go look at it in the UI and just poke around and see where things are busy, where it's expensive. And once you get a chance to look at that for a while, obviously I've been doing this for a very long time, but it doesn't take that long to get a sense of what's working well and where is the stress point in an application. Is it bottlenecked on I/O? Is it just that it has a lot of variance where sometimes it's fast and sometimes it's slow? Is it something different? And I think ultimately once you get a sense of where things are busiest, then you can start thinking through, okay, what can I do to make sure this application performs well on a busy day? Okay, so when I kind of summarize why does the query store work, it ended up taking a problem that required an expert in query optimizers and democratizing that problem into a form where you didn't have to be an expert in query optimizers to be able to solve your problem. And ultimately, this abstraction layer that we added hid a lot of the useless details, enough that you could just be actionable without necessarily having to spend a bunch of time reading my book chapter or studying blogs and books from other people on how to do deep debugging in SQL. And that history that we have there made it really easy for you to say, okay, I was happy yesterday. What was happening yesterday? How do I get back mostly to what was happening yesterday? And if we make that easy, a lot of other problems become still important for us to go research and improve, but they become priority 2 in terms of the customer having high stress in a CSS call. So if I have a query that was slow today but fast yesterday, you can just force yesterday's plan. And in fact, as of 2017, we have a mechanism that automatically will do that for you. It'll just look for a while and go, oh yeah, this new query is slow, the old query was fast. Let's just try forcing the old one. And then if it doesn't work, we'll just undo that. Principle of least surprise. But if it works, we'll just keep it forced, and then you don't have to bother doing anything. You might not even notice that we fixed it, which is great. Ultimately, that means that you don't have to think about a class of problem that before would become an issue for you. And over time, we plan on making that more and more intelligent so that you can get more and more value out of just turning the query store on. Next issue is, okay, if I have to understand the complexity of DMVs to figure out how to look at things and then hope that it's still in the cache, Query store stores things independent of whether it's still in the plan cache or not. It would capture things separately. So the notion of whether something was cached or not did not impact whether you could debug. And under a system with a lot of memory pressure, often you just couldn't debug it because the information from the plan cache was already flushed out due to memory pressure in the meantime. That was not a great experience, and explaining that to an angry CTO was never a fun conversation for me. And then finally, if your system reboots or crashes or whatever, and it restarts, you lose all the plan cache history. Query store would, for the most part, capture enough of it so that you would be able to reconstruct what happened. And that gave you a lot of insights that before you just didn't get a chance to deal with. So this made a lot of problems that used to be really, really hard back in the, say, SQL 2005 era. Now they become manageable. And you can worry about the next class of problem or the next harder problem in your application or your business logic. Okay, I talked a little bit about this at the beginning. One of the parts that we were doing at the time, we were building a feature that never shipped that did plan serialization, binary plan serialization. And that product never actually shipped, but we had this mechanism that seemed very enticing to build a serialization layer for binary plans. The real challenge behind it wasn't that we couldn't serialize the plan. It was figuring out how to rehydrate the plan afterwards. And if you figure out how to think about every single change you ever might make to a serialized file format, you have to think about this. If you look at, say, how Office has to deal with doc files, originally they had the .doc file, and then they had .docx. And they worked on this to try to figure out how do they deal with the problem of evolution of a file format over time. And the first one, the .doc format, you had to be very careful. Every single time you changed the file format, they had versions from, say, 2000, 2003, et cetera, versions of Office, and each of them was slightly different, so you couldn't be backwards compatible. Later, in versions of Office, the docx format was smart enough that you could actually go backwards and forwards in the file format, and it would mostly still work. The problem we had in SQL Server is we had to be extra sure that we could always solve this problem, or else we would crash SQL Server, and then we have a different CSS case. And so we decided at the end just we weren't going to do that. We were going to force instead through logical plan forcing. One of the downsides of this is sometimes you can try to force a plan in the query optimizer, and it'll generate a plan that is pretty close to the one that you forced, but not identical in terms of how it looks to you in the query store. When we go figure out what is the same or a different plan in the query store, what we do is we kind of walk over the physical structures and we do this thing called a Zobrist hash function, which basically does a hash function over the shape of the query plan and some of the elements, but not all of the elements that go into the physical plan internally. And if you change one little thing, you get a different hash. Or if maybe one of the compute scalars is in a different spot, it's logically the same, it'll perform about the same, but it won't have exactly the same hash. And that sometimes leads to people giving us feedback that it's not the same plan. How come it's not the same plan? The answer is, it's close enough. At the end of the day, remember, I got canceled 3 times. I had to spend 7 years getting this out. It works 99% of the time. It turned out to be a compromise I had to make in order to get this thing to actually get out into the market. Ultimately, that works well enough, and you can still logically look at the plan shape to get a sense of, is it close? And while we do have a few cases where sometimes you can't force something, or where forcing something generates a plan that's not quite the same performance as the one we want, it's a very rare occurrence, and we can usually do something about that when we see it as a bug. And I don't know if, for those of you that are familiar, but in 2022, we also added a new feature, which is sort of an extension of this concept of, I want to make plan forcing go faster, because the concept of how long it takes to force a plan can be a different compilation time, usually faster, but not always, than what you would get for a normal compilation. So one of the challenges we see, especially in big ISV applications, is when you have a failover and the application has many, many stored procedures, it takes a while to warm up the plan cache. And compilation is an extremely CPU heavyweight operation. So it goes through and churns, generates these plans, puts them in the cache, and after a while, it'll warm back up and get completely done. But that first period of time where it's warming the cache, a lot of queries are blocking and sometimes timing out until the plan cache gets warmed up. So you can get to a point where the stress load on your application is high enough that you don't actually have the ability to really satisfy the workload until it is warm. And therefore, there is value in being able to quickly get back to a warm state. So optimized plan forcing was a feature that we created with the intention of trying to make that compile storm during a failover better so that you could get to a point where you could actually finish getting back to a warm state faster. You wouldn't get different plans during this period, but you get the same plans as before. So there are continued work that we're going to be doing on trying to make that more and more optimal so that when you have failovers, those become less of a critical event as well in high CPU situations. We see this with a number of our first-party ISVs because they've been trying to run at extremely high scales over many, many databases and optimizing their costs. So they're often running at high CPU. So they don't have a bunch of spare CPU to do failovers and rehydrations of caches. The next topic I want to talk about is about major version upgrades. So one of the challenges that we would have is customers would upgrade from version X to X+1 of SQL Server, and all of a sudden one plan would change, and it'd be like a giant grenade went off into the middle of their application. And they would call us up and be very upset. And so we got to the point where we tried really, really hard not to change any plans during upgrade because of the risk of this type of problem. In fact, I had a large financial services industry where we had this case where they upgraded. They went from a Superdome version X to the new Superdome without testing, just throw out their banking application, and all of a sudden, let's just say a portion of a country's financial infrastructure was not working correctly, and I had to go deal with fixing that. And ultimately, what turned out to be the problem was that they had upgraded without testing, and we had a very, very small plan change that affected just the memory grant for one extremely critical query that was enough to overwhelm the system and cause it so that it wouldn't really work that well until we went and forced that one little plan to be different. And what we really wanted to do with the query store is to prevent that kind of thing from ever happening again. So when we designed the query store, we thought a lot about what it meant to do a major version upgrade. And when we did this upgraded guidance for SQL 2016, what we actually said was, hey, we're going to start putting every single plan change in the search space, as long as it's not a security bug or whatever, underneath the compat level. So that when you upgrade, you get exactly the same search space and therefore the same plans as you would before the upgrade, with the goal of separating I want to install a new version of SQL Server from I want to accept new logic for how the next version of SQL Server should work. And that idea was to separate the notion of purchasing an upgrade from deploying an upgrade. And because you can't go backwards, that meant that if you tried to go do the new compat level and it had problems, you could immediately go back to the old compat level and you'd be back to where you were before, just like the principle of least surprise I explained earlier. So we said, fine, we'll deploy that concept. In fact, we're going to tie it into the query store with a workflow and say, fine, upgrade to the new version, 2016, turn on the query store, capture your plans, make sure your workload is running well, then try turning on the new compat level, use the SSMS views to figure out if you've had any regress queries. If so, your first solution might be just to force the old plan for now. If not, then go back to the old compat level, contact Microsoft, we'll work on getting you a hotfix, and then eventually you can deploy that hotfix and try again until you're happy. And that workflow was far less stressful on a customer, and it meant that you didn't have these outage situations where if there was a major version upgrade, you immediately had to deal with a plan issue as a fundamental must-fix right now lifesite situation. And by de-risking upgrades, we've been able to give customers far more guidance on just turn on this logic and try it, and then turn it off if it doesn't work, let us know. And that just becomes a much simpler conversation for us as Microsoft, given that we have far more customers than we have people in Microsoft to actually respond to them in case everyone has a problem at the same time. Now, by default, if I'm running a large-scale cloud service like SQL Azure, I have exactly the same problem. I need to guarantee that I'm not going to break your plans just by rolling out an upgrade. So this turns out to be exactly the same issue if I need to run a PaaS service as you running an on-premises SQL server. And we modeled it that way so that you'd be able to get the benefit in both places. Okay, so I mentioned that SQL Server initially released in 2016 with this. We also tried turning it on soon after in Azure SQL Database. And we spent a year kind of getting it on by default in Azure SQL Database. And we had to learn a lot there about different kinds of workloads, stress tests. We had to build circuit breakers into the query store so that if it had too much going on, that it would revert to a read-only state and follow that observer pattern rather than hopefully causing problems with your application. So we wanted to make sure that we tried really hard to do no harm as the guiding principle. And that meant that we really had to work sometimes with different customers because there might be certain applications that were extremely chatty they would run lots and lots of ad hoc workloads that didn't necessarily need to be that way. And if you go talk to the customer and get them to adjust, maybe turn on auto parameterization, maybe rewrite how they send queries to the system, they can get to the point where the query store is adding more value to them. So we went through a year of learning how to do this. We would hit issues. Okay, we'd roll out some new fixes, we try again, and we get more and more customers turned on to the query store. Eventually, 99+% of the customers in SQL Azure are running with the query store on, and we were pretty happy with the fact that it was adding value. And later, when we did SQL 2017, we added a couple of new features. So that's when we added the automatic plan regression correction, so the auto force the old plan feature. But we didn't quite have the time to do that in the original schedule. We also added the weight stats information that I mentioned earlier. So those gave additional insights about what was causing the problems in my query, and they were both great. We didn't ship anything in 2019, but as you can see, we have a whole plethora of features that we shipped in SQL 2022. These are also on in SQL Azure for the most part. And they now give you the ability to do a lot more with the query store when it's on by default, because we're persisting information that we learn about your workload and different queries in your workload into the query store so that it gets smarter as it sees your workload run over time. We took memory grant feedback, which is a concept where when we go initially create a query plan, we think we're going to have this many rows coming out of this group by or this hash join, and therefore each of these operators needs this amount of memory, and therefore the total amount of memory the query will need is X. And we might need far less than X or far more than X in order for that query to run correctly. What we've found is that there were cases where we were estimating 10 or 20x more than the actual memory requirements, and that query was run many times. And that would be a bottleneck because we don't let queries run in SQL Server until it has memory to potentially succeed. So we would be queuing multiple versions of the same query trying to run at the same time until there was enough memory, and therefore we would have a log jam effect. But if we could learn, this really only needs like 1/10 of what you're asking for, then we can allow 10 times as many of them to run if we were bottlenecked on memory. So memory grant feedback is the concept of just seeing repeated executions of the same query in the cache, learning I didn't really need as much memory as I thought, and then only asking for roughly the right amount of memory in future executions so that the system can be more concurrent. That turned out to be an extremely valuable feature, especially in analytics workloads, where sometimes the cardinality estimations are wrong, but the plan shape is okay, but that meant the memory grant was wrong until we had feedback to correct it. In SQL 2022, another feature that we've done is DOP feedback. Bob and I think demoed that during PASS, where you might be running a query, and initially it might run with DOP 16, and then we realized, it can run just as fast as DOP 8, and we'll kind of automatically figure out what the right optimal amount is. So that meant that in the same concept that memory grant feedback is optimizing memory, DOP feedback is optimizing how many cores it takes to get the right value out of a system. So we would then persist that into the query store. So if you're running the same report over and over again, you don't have to worry about, okay, is this query tuned? Do I need to put a manual hint on it? It's basically automatically guessing what the manual hint is with trial and error, and doing that for you without you having to do anything. And that means over time, if you've got repeated queries, it's now smarter the more you let it run. One of the big asks when I first came out with SQL with Query Store, I did this big talk at PASS, and people were disbelieving that this would cost a lot of time and very expensive overhead and this and that. Does it work on readable secondaries? And the answer at the time was no. And I hope you can get a sense for if it was canceled 3 times and it took me 7 years to get it out and I had to do the UI without asking, I didn't have resources to make it work on readable secondaries. Luckily, one of my colleagues this last cycle was able to go and lead a team to go make Query Store work on readable secondaries. So as of 2022, you can use readable secondaries to be able to see what's happening there. You can force plans, and all of it captures the readable secondary workload as well back to the primary and stores it in the original primary database, which means that you can have even more insight into what's happening with your system today. We also demoed 2 years ago Query Store Query Hints, Bob and I in the Bob and Conor show at PASS. And that was another popular feature that basically was, if I want to get to the point where I have a query text, I can't change it because it's maybe an ISV app, but I know I want to tweak it a little bit, add a hint. I can see the text, automatically add this hint without the application knowing. That turned out to be very useful to debug and troubleshoot problems, especially when you can't change the query. And that also is in Query Store now. And then finally, the optimized plan forcing feature that I mentioned is also part of what Query Store does in 2022. Most of these features are also in SQL Azure. I didn't put it on the slide, though. Any questions? All right. If I had to look back, when I first did the pitch for the Query Store, this was before we were seriously trying to become a cloud provider. And so a lot of the use cases that I put into the original Query Store were based on traditional on-premises SQL Server use cases. When the cloud came around, many of those ideas did apply, but there were still some things that were different, not all the same. The main things that I think I learned over the past 10 years of us trying to make SQL Azure is that we had, traditionally, when you have like big SQL Server customers, you would spend enough money and you would hire a DBA and you would make sure that that DBA had hopefully some competence in tuning SQL Server. As you get to the cloud, the cost to enter is much, much lower. And that doesn't mean that you don't get expert query tuners working on SQL Azure, but you get a lot of people that have much less experience working on how to tune queries and think about workloads. So you often have a wider variety of some people that are not experts using SQL, and they want auto everything. They want just you to auto figure out how the plan works, how to tune it. They don't really know, and they don't want to know. They want to worry about their app, not about the database persistence layer. And that was something that fit within the model of the Query Store, but has required us to kind of pivot more towards auto star features than what we maybe would have done originally. Because the original Query Store was probably tuned more at the high-end DBA, and now we don't even have a DBA in some cases. So we've had to kind of figure out how do we extend the concept to be able to work for a broader class of user. I mentioned that we sometimes work with internal ISVs like SharePoint or Dynamics. They're all heavy users of SQL Azure. And one of the areas that's become really quite fun is these sometimes now have hundreds of thousands or millions of databases running in our cloud. And when you have millions of databases running, you see all sorts of interesting problems that pop up. Every stress bug that you could possibly ever imagine, every seam that we had in the design will pop up at some point. And therefore, we're constantly working on that tail of issues on how do we make SQL Azure better. And that meant that we have to kind of look at, okay, what are we capturing in the Query Store? How does our query processor work? Where does it start to fail? What happens when it gets low on memory? And that type of work happens because they're all trying to save money. So they're all running at a much higher CPU load than what you would traditionally run a SQL Server at. SQL Server, if you're running at 30% CPU, that's normal. If you get to 100% CPU, that's problematic. Now, it doesn't mean that SQL Server can't run at 100% CPU, but if you're trying to do lots and lots of things for an operational workload at that scale all the time with hundreds of thousands of databases, something will eventually hit a timeout or fail. And you just need to be able to look at those to figure out how to tune them. So the focus there for these hyper-scale or giant ISV applications was something that I could not have foreseen, but I'm happy that we've been able to get to because it's kind of a neat, fun area for me as an architect to play with. And now, finally, we have these migrating customers from SQL Azure and figuring out how do we teach them, okay, what is the power of the cloud? What do you have to do the same? What do you have to do differently? One of the things that we've really had to work with customers on is some would very religiously rebuild all their indexes and statistics every weekend. And SQL Server, especially with rotating disks, this is not a bad idea. You would always get nice clean behavior during the week if you would clean up your messes and have all your indexes be nice on Monday morning. In the cloud, it wasn't necessarily quite as obvious a win. If you don't have resource governance, then doing the index rebuild might tank your application while it was doing the index rebuild, even if it's online. And ultimately, that meant there were bigger trade-offs of, okay, maybe I need to run slightly less tuned to B trees in order to be able to make sure that my workload is running 24/7. So that trade-off between I need a 24/7 app versus I need downtime to do maintenance got more of a spotlight in the cloud. And those customers moving over from traditional SQL Server environments often would need to rethink or work with us on how do they adjust their model of maintenance to be able to get the best out of what the cloud could offer for them. So if I had to summarize, these are some of the lessons that I learned in terms of what the Query Store had to do differently from what I originally designed as we moved into a cloud world. All right, I mentioned that we had SQL Azure on by default and Query Store is on by default there, and 2022 also has it on by default. I was having a conversation with one of my peers. Okay, sorry, there's a question on screen. If a query ran on a secondary, then will it store that plan in the Query Store? If yes, then when and how? Okay, the way that the readable secondaries works is it'll capture the query on the secondary, send it back over the transport that's used for HADR, Hadron transport, and then store it on the primary database because that's the only place writable. And then it'll become available on the secondary to see once the Hadron Transport sends those pages back over to the secondary. So it will then go through replay on the secondary. So the secondary is always running log replay, and you get to see what the current state is as of the most committed transaction there when running queries on the readable secondary. So it has a small delay, but typically it's almost instantaneous. Thank you for the question. Okay. So the main thing from this slide that I wanted to cover is that I was talking to one of my buddies that works on SQL Azure, and he does a lot of the support cases that come in, sort of what my job used to be. And I just asked him last week, what would your life be without the query store on SQL Azure? And he said, I'd rather have just quit, because it was just easier to not do this job than to try to figure out all the things the query store makes easy. So I think that the same applies hopefully to you as a customer, but internally to running the service, I wanted you to get the sense that we depend on this. I have a bunch of engineers now that have no idea how to go back to the old DMV way of doing things because they've only grown up using query stores. All right. So I wanted to kind of conclude based on a few things that I maybe would have done differently now if I could go back in time. So when I first started the query store, we didn't have column store indexes. But in any real sense, it would be much, much better to have the runtime stats stored in a column store than what it is today. It would be faster to run. I could use batch mode. I'd have to do some work on that magic pixie dust to get the DMV in-memory stuff to work with the on-disk stuff, but that would be well worth it. So at some point, I hope that maybe we can go back and rethink that part of the design. The next area that maybe I thought a lot about in the vision document, but I haven't been able to necessarily get delivered, is dealing with dev and test environments. So let's say I have an environment where I'm running in production with a certain set of plans and I force them a certain way, but I want to go back to my dev environment and test the next release of what I want to put out. Well, today we don't have a great way of capturing the state that's in production, putting it in a dev environment, testing that, revalidating, and then redeploying. Or, in other words, if I want to force the same plans in all these different copies of my development environment, can I get exactly the same state in all of those if I want? We don't have a great workflow for that today, and I think that's an area of opportunity that still remains for us to kind of go after. In the cloud, it's a little bit more challenging because we have to logically deploy things, and sometimes they are logically different, but this was one of the areas that I had a lot of feedback on before that I haven't been able to act on yet. Yes, sir. The question is, could backup and restore allow us to do dev test environment testing? Yes, for customers that can take their production environment, do a backup and restore it in development, yes, that is a viable model and the query store would work great. But we do have customers that don't want to have production data in the development environment, and it doesn't work for that. You can do clone database to capture the query store, but there's no easy workflow to apply that into an existing dev environment and make it work perfectly. So all I was trying to call out is, I think this is an area where there's some seams, it's not turnkey, it would be nicer if we could do more. We just have opportunities to make it easier for you. Great. And then the last thing that I think has been important to me is I expected more customers to adjust more applications to fit into the query store to get value out of it. And some have, but I've had a whole pile of customers that have been, I will not change my application and you will deal with that types of put their foot down than maybe I would have originally thought. That's been an interesting lesson for me, but I think lots of things in life are lessons, and this is one that maybe probably I can't do too much about, but it's been interesting to watch the human dynamics of this situation. All right, with that, that's my last main slide. Thank you very much for coming to my talk. I hope this gives you a sense of what the query store can do and why we've been investing in it, and hopefully gives you a sense of the power of what it can do for you. And thank you very much for coming and listening today and for your attention. I appreciate it.